Hi, today we're going over the sine law, or at least the first part of it. We'll finish it in the next section of notes. So the sine law is used when we don't have a right angle triangle such as this one. So in order to derive the sine law, what we will do is break this triangle into two 90-degree triangles. And we'll just call this value here H. And where it connects down here, we will call D. Now, in triangle, so whenever I draw out something that's triangle shaped, that's shorthand for triangle. In triangle ABD, which would be this triangle here, if we take sine of B, that would be equal to our opposite side, which is H, over our hypotenuse of C. What we'll do is rearrange this to get H on its own. So multiply both sides by side length C. So we have C sine of B equals H. Now we'll do a similar thing with the other triangle. So in triangle ACD, sine of angle C is going to be H over its hypotenuse of B. We'll multiply both sides by side length B. So that gives us B sine of C is equal to H. Now, because both of these are equal to H, that means they equal each other. So this gives us C sine of B is equal to B sine of C. Now we'll gradually rearrange this to get the same letters on the same side. So divide both sides by B. That will cancel out the B's on this side. We'll then divide both sides by C. That cancels out the C's on this side. So that gives us sine of B over B equals sine of C over C, which is essentially our sine law, except for we have one additional component, which is sine A over A. Now, when we're using this, we only use two of the three components at any given time. And in the format that's written in now, I would use this for solving for angles because I've got my angles in my numerators. I could also write this with the sides in the numerators as A over sine A equals B over sine C, or sorry, over sine B equals C over sine of C. So this form I would use for solving for side lengths because in this case, they're in the numerators. So less rearranging to solve. So to use for sine law, we need to know one side and the angle opposite it, as well as one other side or angle. So for example, we want to solve for side A. So the first thing I would do with this triangle is label my side. So if this is capital A, this is lowercase a, this is capital B, this is lowercase b, this is capital C, this is lowercase c. I will then, because I'm solving for A, write my equation as A over sine A equals, and then I'll choose which variable I have a side and its angle for. In this case, that would be C. So equals C over sine C. Now we want to get lowercase a on its own, so we'll multiply both sides by sine of A. So that gives us A is equal to C sine of A over sine of C. We'll substitute our values in. So we've got side length C of 25, sine of angle A, which is 49, divided by sine of 32. Which gives us A being 35.6. Okay, so next we will solve for X, side length X. So once again, start by labeling my sides. So we're solving for X, so therefore it will go in the first fraction. So X over sine of X equals, we'll look for the ones that we have both an angle and a side for. Currently, we don't have that for any of these, but we can get our angle Z because we know angles in a triangle must add up to 180. So 180 minus 85 minus 24 is going to give us that last angle, which is 71 degrees. So we have our values for Z. So we have Z over sine of Z. We'll multiply both sides by sine of X. So that gives us side length X is equal to side length Z sine of angle X divided by sine of angle Z. So we have X is equal to Z, which is 37, sine of 85 divided by sine of 71. And that should give us 38.98, so that rounds to 39.0. Next example, we're going to solve for an angle. Once again, label our sides as our first step. We have an angle in its opposite side, so we can use sine. So solving for an angle, I'll write out the form of sine in the numerator. So sine C over C equals sine of A over A. So we'll multiply both sides by side C so that we can get sine of C on its own. So we have sine of C is equal to C sine of A over A. We'll substitute our values in. So we have sine of C equals side length C, which is 7, sine of angle A, which is 100, divided by length A, which is 10. That just gives us sine of C is equal to 0.6894. To get our angle, we now have to go C is equal to sine -1 of 0.6894. So that gives us 43.57. Now, normally if angles, unless specified otherwise, we'll just round to the nearest degree. Just gives us 44 degrees. Now, practice for a section can be found on page 475.